Welcome to the experiment number 7 on directional antennas with driven elements of the lab course of Advanced Antenna System. This experiment is about the demonstration of broadside and end-fire radiation pattern obtained from the array of two half-wavelength long dipole antennas. We know that for broadside array, the antenna elements are to be excited with equal current in same phase, and for end fire array, the antenna elements are to be excited with equal current but in opposite phase. The objective of this experiment is to show how a composite antenna made up of two simpler antennas can exhibit directional radiation. The apparatus required to perform this experiment are RF generator, feeder cable, ground plane, radiation detector, quarter wavelength rods, 2 in number, rods with T connectors, 2 in number, simple rods, 2 in number, and angled rods, 4 in number. As a pre-assembly, connect the different kinds of rods as shown in this figure and use the plastic spacers between the parallel rods to hold the rods firmly. Now, in part 1 of the demonstration, the antenna elements are oriented in a manner that broadside radiation pattern will be observed. Broadside means in the direction perpendicular to the axis of the array. Switch on the RF power and perform the antenna matching procedure. Just observe the current distribution in various rods present over here. The current in this vertical rod gets splitted in two equal current like this. And the current in this second vertical rod will be in opposite direction and is the sum of the two equal currents coming from these two angled arms. So if you observed the vertical rods present here, then current is equal and opposite. And similarly, in these horizontal rods, the current is equal and opposite. And therefore, no radiation could be observed from this part of the configuration. If you observe these vertical angled rods, then each rod is quarter wavelength long, means these are the half wavelength long antenna elements separated by this much distance, and this distance is kept equal to lambda by 2. And the current in both the half wavelength antennas is in same direction. So it's an array of two antenna elements with in-phase excitation, and hence maximum radiation will be observed in the direction perpendicular to the axis of the array. Note that the radiation is vertically polarized as it is coming from these vertical arms. Now, in part 2 of the demonstration, first switch off the RF power and rotate one antenna element of each dipole antenna into the shown configuration. Now switch on the RF power and perform antenna matching procedure. Now observe the current distribution as presented over here. The current in these horizontal and vertical rods is in opposite direction, and thus they will not contribute in the radiations in the far field. The current in these two half wavelength dipole antenna, which are separated by this much distance, which is equal to lambda by 2, is in opposite direction. That you can see from here, the current in this dipole antenna is vertically upward, while the current in this dipole antenna is vertically downward. And hence, they will form an end fire array with the maximum radiation along the axis of the array. Let us now perform the experiment over the kit.
To show the two composite antenna made up was easier and it working as a directive antenna. For this demonstration uses 2 lambda by 2 rod horizontally, and this is a antenna height, and this lambda by 4 antenna and lambda by 4 antenna connected on this lambda by 2 in such a way, this is vertically and upward, and this is vertically downward. Same way at the end, the same, this is downward lambda by 4 and this is lambda by 4 upward. Construction, both antenna lambda by 2 and lambda by 4, it also become lambda by 2, and this radial lambda by 4, it become lambda by 2 radial. So the lambda by 2 radial 1 and lambda by 2 radial 1, it is vertically mounted at the lambda by 2 horizontal rod. So now the tuning is connect the feeder, element connected, power arm forward and reverse, then use for VSWR near to unity. So receive, match, and it is near to unity, this match, and then again put the forward. So constructions detail. Now show the radiation pattern. This lambda by 2 antenna and this lambda by 2 radial is vertically mounted on the lambda by 4. Here in the close vertically polarized, but in the far field there is no radius. And in the same, along with the broader side, now we'll see it is a vertically polarized, just exact 90 degree to the dipole, lambda by 2, 90 degree, and then again at the end there is no polarization, and the same backward, this is 90 degree, so it is vertically polarized. See here and here both elements, current is in opposite direction, so horizontally I am getting the null. So at the end there is no radiation, along with the broader side there is 90 degree fully radiation at up to this. So this antenna broad side, now you can show upward horizontally, this is nothing but vertically I am getting, so it is just 90 degree along with the broader side. So I am telling this is the broad side antenna. Now this type of antenna is used in for communication purpose, only for the monitoring. Intelligence from which direction is coming, so easily we can receive mode, I can receive the intelligence and I can say from which direction it is coming. This is also two composite antenna, but here it changes because this element, it is just mounted on the horizontal rod in one direction, and this element mounted on the same horizontal rod in opposite direction, because entirely from the earlier broadside and broadside it is changed. So I will call as a end fire antenna. How it work? So now earlier we were getting along with the broader side radiation, but just we will not get now, we will get at the end. So this is the vertically mount, so now radiation from as end. And the same way, they vertically, along with the horizontal, there is no radiation, but at the end, there is radiation. So I can say the polar, it is just from the center, it is just at the end, and the same way at the end. So I can call as the end fire antenna. It is also a directive antenna. Mostly the broader side antenna or end fire antenna used for the disruption mode, only to find the directional activity. So both antenna, I can say it is the directive antenna. So this is the conclusion. Uses, this both antenna can be used to monitor the signals, intelligence to receive mode.
As conclusion, we can say that two or more antennas can be combined to make a more complex antenna. having directional properties. The directional properties can be changed by changing the phase relationship between currents or the relative positions of the antenna elements. The applications of such an antenna array is in direction finding. As a precaution, switch off the RF power before changing the array configuration. Thank you.